Brilliant. I think it works now. Awesome. Okay, so I'd like to talk about how businesses and critical infrastructures could use the TURNkey platform to boost their resilience. As you may know, earthquakes in Europe have been devastating, close to 20 billion euros in damage in just 10 years. So the purpose of TURNkey is to boost urban resilience to earthquakes, and businesses and critical infrastructures play a key role in that. Here are some examples of critical infrastructures. You have things like food and groceries, energy, transport, communications, hospitals. You can see why critical infrastructures are essential to urban resilience. So what we've looked at is how we can improve the resilience of organizations using the TURNkey platform. So resilience in the context of organizations refers to the ability of organizations to continue to perform, to survive and prosper, even in the context of an earthquake. So we've looked at earthquake management support that TURNkey could provide to critical infrastructures and businesses, looking at all the different features that TURNkey offers, from simulations to forecasting to earthquake early warning, and to the response dashboards to see what businesses and critical infrastructures could do with that. So when we spoke to potential end users of the TURNkey platform about organizational resilience and how TURNkey could help with that, we looked at three aspects. The first is minimizing downtime, like how organizations could use TURNkey to minimize downtime, which refers very much to physical resilience. So it refers to the buildings, the architectural components of buildings, but also to production systems of organizations, like the physical things they use to produce the key good or key service that they provide. The second thing we looked at was minimizing disruption, what TURNkey could do to minimize disruption. So that looks at operational resilience. So it looks at management as opposed to the physical part of an organization. So you look at things like contingency planning, managing external relationships of an organization like supply chain, and also, of course, disaster and recovery management. In general. And finally, we looked at minimizing losses, which refers to economic resilience of organizations. Now, that doesn't just refer to financial management. It also refers to things like managing, your corporate image, your public relations in times of an earthquake, which could have a significant impact on your financial situation down the line. And we also looked at something called adaptive capacity, which is the ability of organizations to adapt in the context of change, like an earthquake. So the approach we used is called participatory action research, which is an iterative process whereby we sat down with end users and also the people developing TURNkey, discussing what end users need from TURNkey, but also what's possible from a scientific and engineering point of view. And we went through a loop of, planning, acting, observing what happened, reflecting on that, and then planning again. So what I'm presenting today is based on the final round of participatory action research, round 3. We spoke with critical infrastructure providers and businesses in Romania, Greece, France, the Netherlands, and Iceland. So, we always started off by giving a quick overview of the TURNkey platform, explaining it is a scientific engine, it provides simulations, forecasts, early warning, it has a response dashboard, and we would explain how TURNkey gets its information, how it gets it from different seismic networks at national, regional, but also at the building level, if there are sensors at the building level, also from telephones. We explained it integrates information from eyewitnesses, and then it uses all that information to provide the outputs that businesses and critical infrastructure providers could use to boost their resilience, potentially. So we did it chronologically. We followed the disaster management cycle. So we started what organizations could do long before an earthquake or before an earthquake. So we explained operational earthquake forecasting as a probabilistic assessment of the likelihood that an earthquake of a particular magnitude would happen in a particular location at a particular time. We explained it's not a deterministic prediction. We made the comparison like it's like an extreme weather forecast. And we also, okay, that text is completely illegible. We also explained how OEFs are calculated at a very top level manner, that it looks at the difference between background seismicity and real-time ground motion data, and that it uses, it calculates if and when an earthquake exceeds a preset threshold, and that users could set that threshold, and that they could also change the uncertainty of the forecast, which is very important to end users. I wish that was more legible. Anyway, so the use case we identified for operational earthquake forecasting is that businesses and critical infrastructure providers would use it to trigger their existing disaster management plans and business continuity plans early. Like they'd have the confidence to know that there is an increased risk of an earthquake. So they could minimize their downtime by using that knowledge to, protect critical data, get systems ready, make backups, what have you. It could also minimize disruption because it would allow them to put, personnel on standby, make sure that, everything in the supply chain is working, do checks that all the systems and processes are working. And so what's needed for that use case to be successful is that the platform provides daily assessments of the probability of an increase in the seismic hazards, and also very much that end users can change the uncertainty of the prediction. So in this last round of participatory action research, we sat down again with end users to ask, if your organization had the ability to run operational earthquake forecasts, if you could do that, would you use it to inform, the mitigation actions I just described? And most of them said that they probably or definitely would use that information for those purposes. However, some did not, and there's two reasons for that. The first is that some organizations are based in very earthquake-prone regions, and for that reason, they are basically earthquake-ready at all times. Their buildings are built to withstand earthquakes of a significant magnitude, but also their operational procedures are designed for them to withstand earthquakes. So there is very little extra that they could do with that information. They're basically earthquake ready at all times. And there's also another reason why some organizations did not want to use it. Obviously, critical infrastructure providers some of them provide a public service or a public good. And so for them to choose to reschedule their services or their goods based on an in-house forecast, and if the earthquake doesn't materialize, even though it was forecasted, then they would be legally liable for that. And obviously they did not feel comfortable with that, and so they expressed a view that these forecasts should come from authorities, and that if they had to reschedule their services or do something to the goods they provide, then that should be an instruction from a legal authority, so they wouldn't be legally liable. So therefore, the caveat for organizations using operational earthquake forecasts is very much that it has to be a very conservative forecast. Like it has to have a very low level of uncertainty for them to take action, to take mitigation actions. So then we discussed simulations. So we explained that the TURNkey platform, it uses the information from operational earthquake forecasting to then run simulations to see what would happen, how the forecasted earthquake would impact assets and physical and economic losses. So that's one way in which TURNkey provides simulations. We also explained that there is an alternative option, which is that they can run simulations manually. They can enter the magnitudes, epicenter, etc. themselves. And so we identified 3 key use cases, 3 ways in which businesses and critical infrastructure providers would use simulations to boost their resilience. The first of all is for them to have an understanding of the impact of different earthquake scenarios on their individual built assets. This would help them improve their business continuity and disaster management plans. It would inform training exercises. And it would enable them to look at the supply chain and see, where bottlenecks might be upstream and downstream. Would also help minimize financial losses. It could boost their economic resilience because it would give them the opportunity to see if, for example, insurance is needed for a particular earthquake scenario. So what's needed for that is basically an assessment of different damage states, estimates of physical, human, financial losses, shake maps, PGA, and structural damage states. And what's very much wanted was for end users to toggle the uncertainty levels. So the second use case is very similar to the first one, except for it would allow infrastructure providers and businesses that have assets across a region to make a regional assessment as to the impacts of different earthquake scenarios on their regional presence, and then they could, prepare accordingly. The final use case for simulations is to do cost-benefit analyses. It would help minimize downtime because it would help organizations assess the benefits of, for example, retrofitting or changing their service model, depending on the outcomes of the different simulations that they would run. So in this last round of participatory action research, we sat down again with end users and we asked them, if their organization had the ability to run earthquake simulations, would they use that information to inform the mitigation actions that we've just discussed? And obviously most said that they would, that they probably would, or that they definitely would. A small number said that they wouldn't. And for those that wouldn't, they basically said, we already received the information we need to do all of this from other trusted sources like the MET, like the Met Office. And they have systems in place, processes in place for doing this. So this would, for them, this would be duplication. So that's why they said that they probably wouldn't use this. It would be, but most said that they would. So then we went along the disaster management cycle to when an earthquake actually hits. So we went to earthquake early warning. So we explained to people, how earthquake early warning works, that they get an alert, for when ground shaking is likely to affect them after an earthquake has started. We explained it's about the difference between the S waves and the P waves. I can't remember which one is which. And we explained that if ground shaking exceeds a preset level, a preset threshold, then they would get an alert for ground shaking. So there's 2 use cases that we identified that critical infrastructure providers and businesses could use for early warning. So the first one is to improve the safety of people either on site or in a transport system. So the idea is then this requires the people at those organizations who have had training to know what to do when they hear an alert. But assuming that they've had training, they've done drills, then if they hear an earthquake or they hear an audible alert, they can then take action. Like if they're working with hazardous systems or equipment, they can put it in safe mode. They can, if they're in a very dangerous location, they can try to get away from it, and then they can prepare, drop cover and hold. So what's needed for this? So the idea would be that civil protection would be sending the alert to the control room of a critical infrastructure provider or a business, who would then issue an audible alert to affected areas on their sites. And the second use case would use the earthquake early warning alert to protect the damage to systems within the critical infrastructure business that are highly vulnerable to ground shaking. So here the idea is that either operators hear an audible alert and they manually put things in safe mode. There's also the possibility of integrating TURNkey with automated systems. I mean, that's not something that has been done obviously yet, but it's technically feasible. And it would also minimize disruption because it would allow key personnel to initiate their disaster management response protocols quickly. And so we sat down with end users again for this last round of participatory action research, and we asked them, if you had the ability to receive earthquake early warning alerts for main shocks or aftershocks, would you use them for these different mitigation actions, which I've just described? Now, most said that they probably would or definitely would. There's a few who said that they probably wouldn't or definitely wouldn't. And again, that's organizations who either don't have any hazardous or vulnerable systems that they need to protect, because that's what those questions ask. They don't have hazardous or vulnerable systems, so they wouldn't use it for that purpose. Or alternatively, they are based in an earthquake-prone region. They are already completely earthquake-proof at all times. So an alert wouldn't enable them to do anything additionally. So finally, we discussed how TURNkey could support critical infrastructure providers and businesses during the response after an earthquake. So we discussed that TURNkey issues aftershock alerts, that it has an app that has the feature MI Safe, which allows team members who might be doing repairs in dangerous areas to inform their team that they're okay or not. We talked about the different features on the dashboard, how it shows how different assets have been affected, how different areas have been affected, and also that it shows the progress of the response, the different measures that have been taken. And we discussed with businesses and critical infrastructure providers how they could use this information provided by TURNkey. So the first use case that we identified was for critical infrastructure providers and businesses to identify key areas for intervention and monitoring. And this could help minimize downtime because it would show which areas, which assets need to be repaired as a matter of urgency. It would also help minimize disruption because it would show what's still functional, what's no longer functional, and they could adapt their contingency plans accordingly. Now, in order for this to work, a lot of bespoke information would need to be added to TURNkey beforehand, or TURNkey would need to provide this information that third-party actors could then use. So like, for example, if TURNkey was fitted with a sensor in a building, then, the bespoke estimates for interstory drift, etc., would need to be provided for this use case to be effective. The second use case that we identified for critical infrastructure providers and businesses
was improving the safety and the effectiveness of a response by improving coordination and communication. So the idea would be that it would minimize disruption because there'd be one central place for command and control, and different stakeholders could share information and communicate via the platform. So features that are relevant here are the app that allows team members to report whether or not they're safe to receive after they've received an aftershock alert. The email management system that allows people to communicate, send messages via the TURNkey platform, and regular updates about the response and how it's going on the site. So we asked critical infrastructure providers and businesses if they had access to this information, would they use it during a response? And most said that they probably would, or definitely would, but some said that they wouldn't. And the reason that they said this was because they felt that crisis response is first and foremost the responsibility of government authorities. And so they felt, and so the reason why they said they probably wouldn't use it was because they felt that this dashboard should sit with, for example, civil protection. And others said that they probably wouldn't use it because they already have systems in place to do these different activities. So in conclusion then, we asked the potential end users, we asked the critical business providers and the critical infrastructure providers and businesses how they felt and whether or not they felt that TURNkey would improve their organizational resilience. So when it came to minimizing downtime, to summarize what they said, like they felt that the impact was moderate, whereas when it came to minimizing disruption, so which is about operational resilience, they felt it was moderate to high. And when it comes to minimizing losses, they felt that the impact of TURNkey would be moderate. And this is the more detailed how they responded for each asset of organizational resilience. So there's a lot of buy-in for the idea that TURNkey would help with contingency planning, for example, whereas people are more skeptical that it would, for example, help with, corporate image, which is a reasonable thing to say. So those are the findings from our last round of participatory action research. If you have any questions.